Okay, the second example for this lesson states the function p of t equals 20t over t plus 1 models the population in thousands of Nickelford t years after 1997. The population in thousands of nearby New Ironfield is modeled by q of t is equal to 240 over t plus 8. Determine the intervals of t where the population of Ironfield is greater than the values of Nickelford. So again, what is this question asking us? They're looking for us to tell them the intervals of t where Ironfield's population is greater than Nickelford. We have two functions given to us that represent each of the two towns' populations. Let's set Ironfield, which is q of t, greater to p of t, the population of Nickelford. So I'm going to have q of t is greater than p of t. And when I substitute in my equations or my functions, I'm left with 240 over t plus 8 is greater than 20t over t plus 1. And now we have a rational inequality. Let's go back to our skills that we acquired in lesson 5 and use those to solve this rational inequality. So first step, I'm going to bring my p of t function over the greater than symbol and subtract it from my q of t function to be left with this. And now when working with a rational inequality, our next step is to find a common denominator. So our common denominator will be the product of t plus 8 and t plus 1. In order to do that, I multiply the opposite piece by whatever it's missing. T plus 1 for 240 over t plus 8. And for our other side, or our other term, we're multiplying that by t plus 8. So we're going to look something like this. 240 multiplied by t plus 1 minus 20t times t plus 8. I'm going to put that all in a square bracket just so we remember that we do need to distribute that negative once we have simplified and distributed. So on our denominator, t plus 8 and t plus 1. Now I work through my expansion, my distributing. I'm left with 240t plus 240 minus, I'll take one extra step here, 20t squared plus 160t, still all over t plus 8, t plus 1 greater than 0. And here I can distribute in my negative. I'm going to skip the step here, and I'm going to go right down to my simplified solution of negative 20t squared. When I distribute my negative to 160t, it becomes negative or minus 160t. So 240t minus 160t leaves me with 80t plus 240 all over t plus 8, t plus 1. And that's all still greater than 0. So we're getting there. Our next step, as we know, we need to factor our top in order to get our key values to set up our interval table. So that numerator factored is going to look like negative 20 t squared minus 4t minus 12 all over t plus 8 and t plus 1 greater than 0. My numerator can factor using product and sum, product of negative 12 and a sum of negative 4. So I'm looking at negative 6 and 2 as those values. Negative 20 multiplied by t minus 6, t plus 2, all over t plus 8 and t plus 1 greater than 0. Now I have my values. I'm able to set up my interval table. Remember, when we're solving an inequality, we need to have an interval as our answer. This question was nice and reminded us that we needed an interval. However, don't make that mistake that if you're solving an inequality to tell me that t equals 5 or t equals 7. We do need to have an interval. So let's set up our intervals based on our values. We're looking at our vertical asymptotes and our x-intercepts. Vertical asymptotes are going to be -8 and -1. Those are the values that make our denominator equal to 0. Our x-intercepts are 6 and -2. Now we set up our interval table based on these values here. We are able to simplify or shorten our interval table because we are working with a function that is described as t years after a particular time. All of our negative values of t are going to be irrelevant for us. They do not exist for this function. It's t years after 1997. There is stuff going on with the math on that side of our interval. However, we don't need to concern ourselves with that. So we are able to set up our intervals. We don't need to include this this vertical asymptote, and we don't need to include this. They're both to the left. We're not concerned with what happens over there. So we can leave those vertical asymptotes out of our interval table. We'll include both x-intercepts just to see the math that goes on. Set up our interval table, -20, t minus 6, t plus 2, t plus 8, t plus 1, and f of x. It's going to be a little bit of a bigger interval table. So setting up our intervals, t is less than -2. -2 is between, t is between -2 and 6. And t is greater than 6. So pick a value within each interval. -3 minus 6 is negative. -3 plus 2 is negative. -3 plus 8 is positive. -3 plus 1 is negative. So two negatives make a positive. Two other negatives make a positive, and I have a positive here. Now I have 4, which is a negative there. 4 minus 6 is negative. 4 plus 2 is positive. 4 plus 8 is positive. And 4 plus 1 is positive. Two negatives make a positive here, and the rest are positive, therefore that is also positive. And now for our last interval, everything greater than 6. I have a negative. 7 minus 6 is positive. 7 plus 2 is positive. 7 plus 8 is positive. 7 plus 1 is positive. 4 positives and a negative. The product of those is all negative. Now, going back to our question, we've finished our interval table. We've got a positive interval here. We have a positive interval here. How do we interpret this? We were looking to solve the equation or solve where the function is greater than 0. As we stated before, we're not concerned with anything prior to 1997 based on our model here. We are looking for everything beyond 1997. Therefore, we are able to say that the population of Ironfield was greater than Nickelford from 0 to 6 for t, but to actually describe that in a way that makes sense for this question, from year 1997 to 2003.